Thanks so much, everyone, for joining today's session on next level network automation for the power grid. I'm Jeffrey Tufts. I lead utility solutions globally for Cisco. And so let's go ahead and kick it off and get started. So today, joining me today, we have two really great guests that are going to help us tell the story about where network automation is and where it's going within the utility space. So really pleased to welcome in Marcus Smith to the conversation, a chartered engineer from Cisco that leads up our utilities and renewables solutioning and validated designs, and then Dan Bayoth, professional engineer from Burns & McDonnell. Between the three of us, we have close to probably 75 years of experience in OT networks, predominantly in the energy space. So that's who we are today, and I'll say it at least once more. And thanks again for Marcus and Dan for joining us today to really help us dive into the topic. So, with that, excuse me. With that, let's move on. So, what we'll look at today here is we're just going to open up with a baseline of network automation. What is it? Where was it born from? What are some of the benefits, and so on, just to give everyone sort of a base level of understanding of network automation. Then we're going to dive into a conversation with Dan around network automation, specifically in the energy operations or OT space. We'll close out with Marcus on the validated design work that his team is doing in the labs, specifically around OT network automation. So that's what we're up for today, and with that being said, let's dive right in. So digital transformation, the digitization of energy, all of these things go by a number of different names, but we started this process of digitizing things in the energy space almost 15 years ago, and it is sort of progressed at a pretty consistent slope, if you will, probably until the last several years. And you can see some of the drivers that we called out here. Certainly from an enterprise side, think people working from home, moving workloads to the cloud, those types of things. Certainly COVID expedited things on the enterprise side. But specific into the operations space, we've seen the sustainability and DER investment and deployments create a fairly significant disruption in the distribution grid, going from one-way power flow to two-way power flow, and all of the state telemetry that's required to keep the distribution grid in balance. Certainly has driven a good bit of digital transformation, distribution automation, and all the benefits that come with that, whether it's efficiency or improved reliability of the grid. Certainly have driven a number of digital initiatives out in the grid, and of course politics, geopolitical, if we're looking at things, for example, in Europe, when it comes to being able to quickly change where our source of energy is coming from, and moving energy around a little bit differently on the transmission side than perhaps was done a year and a half ago with what's going on in the Ukraine. So that being said, is in the same way we saw, I suppose, a digital transformation on the IT side over the many years, we're seeing it and continue to see it, and the slope of that graph, the ramp of adoption is accelerating. For the reasons I mentioned, but the other piece of it is, of course, I suppose this intersects with politics, is there's a lot of funding that is taking projects that might have taken 10 years and accelerating them to 5 or 7. And so that's adding a little bit of fuel to the fire as well. So lots happening, lots changing, but underlying it in sort of the foundation of today's topic is that there's a lot of digital assets being deployed, or previously unconnected assets being connected to get telemetry or to be able to provide automation and so on, as I mentioned. So with that sort of foundation in place, let's move on to another. So what is generally network automation, right? So we're looking to automate really the whole life cycle of the network. So as you can see here, we pull out a couple things, whether it's configuring, testing, deploying, and operations of both the physical and the virtual components of the network. And so really it's taking what was historically a pretty human intensive operation, and moving it into some sort of orchestration, a level of automation, just taking those human tasks. So at the base level, taking some human tasks and automating them. And then as we go higher up that value stack, taking some disassociated components and adding them together, which would be orchestration, right, with business rules. For example, I want to add an IED. We then push out all the different IT aspects, whether it's turning up a substation switch, putting an entry into your distribution management service, and so on. So that's generally speaking network automation. And so, where is its genesis? How did it come to be? If we look back, probably just as recently as 5 years ago, about 95% of network changes were performed manually. And so this really had two challenges, right? So certainly I call out the first one here is that the operational cost. So for a significant network, we can look at just operating the network could be 2 to 3 times higher than the actual cost of the network. And so, that's a key intersection with utilities, right? So in the energy market, our core line of business is not operating networks, right? It's providing power. And so when we have an asset that costs several times more to actually just operate it, that isn't our core line of business, that tends to rise up, and we tend to see that as an opportunity to do something about it. The other piece of it is, if you think about the networks that we're building in the OT space, right? So they are the foundational component to the digital use cases we're putting out there, whether it's fault location and isolation, teleprotection, voltage optimization, and so forth. Those things are enabled by the underlying network. And so the reliability of that network starts to become correlated, or I should say the reliability of those use cases in the underlying grid starts to become correlated to the actual OT network that is supporting it. And so we call out here, a stat that has been around for decades. My whole career is that human error is by far the leading #1 cause of network outages. And so the intersection that we see between, well, geez, it costs quite a bit of money to operate a network, and if we're doing that through human labor, that's also likely the cause of our #1 network of outages. So those two pieces on the IT side really came true and were brought forward by the vendor community to address those, and then was born and has been significantly adopted on the IT side of network automation, and then, as I alluded to, some network orchestration and so forth. So that's how we've gotten here. That's how the vendor community got here, and that's largely how IT has arrived here as well. And so just to take a look at certainly automation, as you can imagine, if we go back to some of the first components of automation, we can think of, say, for example, Henry Ford and what they did with automation and creating the Model T, right? And so speed was a big component of it. And so we'll call out speed, but with automation, it's probably better to say it's speed with accuracy. And that's really the combination that we find most compelling, or at least the customers that I talk to find most compelling is the combination of being able to have the speed and velocity to do certain things that the business is asking us to do on the OT network, but doing it with the accuracy and the reliability that is warranted in the OT environment. So really what we want to do is OT, as suppliers and partners in the OT networking domain, is we want to be enablers and not hindrance. And what I mean by that with respect to speed is, if we're trying to roll out a particular automation scheme on a troublesome distribution feeder, we don't want to be, the OT network certainly does not want to be the component of that project that slows down the time to value of that use case, whether it's Flizzer or whatever the case may be. So there is certainly a speed component, but it's not without saying that speed with accuracy is an area that we need to really focus on. So the other piece that we'll call out here, and one of the underpinnings of the value that we can see with automation in the OT environment is that certainly as things become more complex, they slow things down. The other piece of complexity is if we layer in that human element, is going to be with complexity comes errors, right? And so that's why we've always had the keep it simple mantra and so forth. But there's a lot of things that we can't keep simple anymore, right? So I call out the first one on the top left here, which is security. So particularly in the bulk electric system, let's say on the transmission side or in some of the larger generation facilities and so forth, not only are we being asked to do things more secure from a regulatory standpoint, we are being told that we need to do them internally, simply from a risk and business continuity standpoint. And so those security postures are becoming more and more sophisticated and complex. We're leaving the days of, this is just about security boundaries, think VLANs, rudimentary firewalls, and so forth, and we're needing to get much more complex and depth. Think security visibility, microsegmentation, deep packet inspection, those types of things, right? And so that posture is really driving, from a lower level, a much more significant configuration. And so that's just one example of how things are getting more complex, and we need to be able to ensure that we have accuracy in terms of that security policy. And so you can start to see the groundwork of why automation, particularly when security is being layered in and that security is becoming more complex in some of the bulk electric sites. But I call it a couple items here as well. So network migration, we're certainly moving, there's no shortage of networks that are moving from legacy, whether it's SDH, PDH, SONET to packet, whether it's 3G to 4G, public 4G into private 4G, 5G on the field area network. But there is even new networks, as I alluded to on the move to private networks, there's a migration component. And so that migration component is also a nice target for network automation, as that's largely what the service providers leverage in the network automation stack is for network migration and adding of capacity and so forth. So there's a whole other, there's a number of other items here, certainly network upgrades. I think Dan and Marcus will talk about that and the value of automation. But nevertheless, it continues the trend of speed, accuracy, and being able to accommodate whatever complexity is moving forward in the OT space. So we talked about speed, and we wouldn't think, in the OT environment, speed is not necessarily our number one driver, and that is the case, with some exceptions that we'll talk about. But what that gives us is the ability to actually do things at some pace, but really underscore this component, and that's with repeatable quality. Quality having a correspondence to accuracy, which of course correlates to reliability. And so that's really one of the underpinnings of where OT networks, their associated managers and architects are sort of really giving this notion of automation it's light of day, it's opportunity, and so forth. The other piece of automation is once you have this sort of centralized view of your network, which is in part the architecture of automation, is having sort of a centralized view of it and being able to push that centralized view out into the corresponding nodes, network elements, platforms, software, and so forth, is that centralized view can create a bit of a digital twin. And so we'll talk a little bit about that notion of a digital twin for the OT network and some of the benefits that has when we dive into the discussion with Dan shortly. The other piece that I'll call here is, if an IT organization and a corresponding utility is using some level of network automation, we start to see a marriage between what IT is doing in terms of rolling out, monitoring, managing, planning for changes, planning for upgrades, planning for moves and adds, and so forth. We start to see some sort of, I suppose, efficiencies of scale of process that we'll touch on as well. So just a little bit of a call out here in terms of, what is some of the things sort of enumerated here. So reduce time to achieving whatever that business outcome is, being able to get to the speed and autonomy of that use case and so forth. But if we look at those smarter decisions and so forth, that really starts to pull in the notion of a digital twin, being able to troubleshoot things offline in that digital twin, as well as predict how things are going to change offline before you make that change. It really drives some operational excellence to avoid some unfortunate outages that we've seen. And so finally, if we're looking on, what this notion of modernized operations is, the part that I would pull out here really is trustworthy, right? And so it pulls from the notion that I've already established, which is if we have a certain security posture, if we have a certain firmware, whatever the case may be, we want that level of automation to be able to keep track that we have a system that's as trustworthy as we hope it is, and intended it to be. And so finally, we're looking at the visibility from an automation standpoint, again, being able to have that centralized view, have the insights, and do the actions that we've already talked about. So if we take just a simple high level view of utility network automation benefits, there's a whole host of day zero, leading up to deployment, sort of day of cutover, and then operational moving forward, that we'll touch base with Dan on, whether it's this notion of zero touch deployments or a life cycle across the board. So these tend to be some of the principal things that are the early adopters are looking at to leverage from an OT environment. So with that, I want to pull Dan into the conversation. As I alluded to earlier, Dan's been at this for some time. I think Dan and I have worked together for almost 15 years. And partnered deeply with Burns & McDonnell over the years. They have just a fantastic intersection of operational experience in the energy space, building out substations, transmission lines, as well as Dan's group that builds the OT networks. And so really pleased to welcome you, Dan, today. And if you wouldn't mind jump in, tell the audience, if they're not familiar with Burns & Mac, just give them a little bit of a brief overview, and then we'll dive into our chat.
Yeah. So real quick view, Burns & McDonnell just started our 125th year in business, founded in 1898. We're now 13,000 plus professionals and 100% employee owned. We are a engineering construction firm, and now we've reached kind of a global presence as we've expanded well outside of our headquarters, founded in Kansas City, Missouri. We now have offices across the entire globe, from India to the UK. As far as our scope of projects for Jeff mentioned, we build substations, transmission lines, generating plants, but beyond that, airports, hydroelectric, food and beverage processing, anything that is large infrastructure, our company gets involved in one way or another, from the full design and build. And then, Jeff mentioned my group does T&D and just about any form of mission critical communications for processing plants, generating facilities, airports, as well as, our core business in T&D. T&D communications wise, our group works from anything from consulting and business case development. And then we also have a team that is 24/7 operations for utility networks, and we really fill any gap in between there, from the design through installation, turn up, commissioning, and systems integration. So our team has kind of grown in scope from the old days of utility comm used to be a necessary evil to get things done, and now it has become almost the enabler for the big wide area distribution expansions, distribution modernization programs that are really going full speed today.
Yeah, and I'd be hard pressed to look at this picture and think of a packet that would pass in support of the electric grid that isn't going across some of this. It's not obvious to me, but I think you have pretty much everything covered with respect to digital operations of of the grid, and I think we've worked together in most of those. So Dan, take us through what you're seeing as just general industry trends in the energy space, and then I'll come back in and we'll talk a little bit about how these intersect with network automation.
Okay. Yeah. The broad category, digitization of energy, just kind of a blanket term for how much more communication is needed to enable things like, well, the distribution modernization enabled by a distribution field area network. That communication is becoming absolutely critical to operation of the grid, where we're now in a world where we're getting towards a two-way power flow, where rooftop solar for commercial and residential, we have electric vehicles coming home, chargers, and all of this is creating a very dynamic distribution grid, which was never designed for that. So now we have things like circulating currents and conditions in the distribution system that 10 years ago we didn't even, maybe we thought about it in the far off future, but were not an issue. And now we're looking at, say, a distribution recloser gets deployed. It has protection settings, and you might have set that, 10 years ago, you'd have set that and just forgotten about it. It'd be done, it'd be under local control. But now we have devices that need, depending on weather patterns, need settings changes, or may need settings changes 8 to 10 times a day. And we just can't reliably operate the grid the way we used to in the distribution system.
So in the distribution, with those use cases, Dan, what are you seeing, with your team kind of supporting utilities to build out that operational communications infrastructure? How are you seeing that impact the OT networking groups within utilities?
Yeah, I mean, that plays right. So the transmission and fiber networks that have been built out for the last 20 plus years as fiber optic and SONET and now packet networks have rolled out to support transmission. This is the next move out from there. Those are now the backhaul network for these field area networks, whether they're, and really the field area network could be public cellular, private cellular, 4G, 5G, but we're moving beyond what we used to get away with on typically narrow channels and mesh networks of kilobits per second. We need more real-time operations. So now we're pulling more data, and there's more demand. It's going to increase the demand on those transmission fiber backbone type networks as becoming the backhaul for FAN, in addition to all of the transmission functions they've been serving for their since they were built.
And what sort of volume are you seeing going out into the distribution grid, and just in terms of connected devices? And if there is a volume, what do you see as the intersection there with network automation?
I mean, volume-wise, if you go take the reclosers, volt-var controller, smart fuses for utility in a single state, that could be 10,000 plus devices easily. It just depends the scope and how much control you need. It may not be needed as much in rural areas as urban, where you're going to have more customers taxing the grid with electric vehicles and adding more solar. But you're getting into a scale of devices where you said, hey, we have 500 devices or communication, transport nodes in our big fiber network. Now we're looking at, let's just say it's 10,000 devices or even 5,000 devices. These are huge numbers of things to have to manage. And I feel this is going to be a big driver to automate everything that is going on in that field area network to manage that quantity of devices. Because, you said, the O&M cost to administrate manually is 2 to 3x or whatever statistic we had there. We simply can't scale that to 10, 20, 30,000 devices. And then what if your FAN network becomes the AMI network as well? And now I've got 1 million devices on it. And just managing something in that scale has to be done with automation platforms of some sort. And because the human hours to do it, if you could afford the staff, you likely couldn't even staff up that many people with constraints in like skilled labor.
Yeah, and I think, with sort of interpreting what you're saying, part of, automation, orchestration, all of this has a lot of components to what it means. But specific to the fan, I think what you're driving at here is how do we get these things deployed, right?
Mhm.
And how do we do it? How do we do it accurately? And how do we do it in mass? Seems to be the aspect of automation that intersects with the fan. Does that seem to characterize that correctly?
Yeah, if I need to, as part of a project, we're going to get all. Let's just target kind of an easy to discuss asset. Like, let's look at reclosers. Hey, we need to do this. We need better distribution automation schemes. I need smarter reclosers with communication. And my field assets are aging. And as part of this program, I'm going to go replace those. I will need a qualified electrical worker, a line worker, somebody who's going to go install that cabinet and get it connected to the recloser. And if I have to have a separate person come by to provision just the communication device, even on site, off site, wherever, I'm just doubling up on labor. So that deployment is just the beginning of where I need less human touches on everything. I need, that the touch to the modem needs to be to place it in the cabinet. The provisioning side should happen as it comes on the air and it's identified as, hey, this is the recloser modem in this cabinet. Here's your settings. You're off and running. Because I have a different worker out there who's skilled in installing it and qualified to install it versus the skilled person who could sit down and manually program it. And I'm just doubling up labor. And I need that. I need all of those steps to happen automatically after I've defined, here are the security policies, here are the settings, here's the whatever security tunnels or anything else that needs to be provisioned on that communications device. That needs to be automatic when it's powered up by the person doing the install for that cabinet. And so, to your point of, we just need to reduce human touches on all of this, because as we scale up the number of devices and the speed they're being installed, we can't double and triple up on the number of people doing it like we probably did when I said, I have 15 reclosers on an MAS radio. Okay, well, 15, that's totally doable. We're probably not going to save a lot of time automating a whole lot of this. And one of the hindrances to automation has been older equipment in the electric, grid communication system. There's just that, utilities like to put stuff out there and run it for as many years as they can get out of it, because it is disruptive to do these upgrades. And some of those legacy devices are not things that are easy to automate. They just weren't designed for it. You don't have API access into things, or you might not even have a central management platform. You just have discrete devices in the field because, hey, when this is installed 15, 20 years ago, this is the device we used, and it worked really well to get a little bit of information out of the device every so often. So
Yeah,
we have this big
one of the
shift.
things. Oh, my apologies, Dan.
No, go
Finish
ahead.
up.
Go ahead.
I was just going to
No,
say
I
one of
just
the
think
things
we
you
have.
touched on in terms of the evolution of the field area network, and let me just take a step back. Just notionally, so the field area network is loosely, the network that would cover a service territory. Oftentimes, it's a radio type network, but could be a mix of radio and fiber. For example, an LTE network built over a service territory might be considered a field area network. So there were the early days, as you alluded to, that there could be these mesh networks that were leveraged for some of this telemetry and so forth. And I think we've seen a move towards moving to LTE, even private LTE and so forth. One of the things that struck me when you said that is, some of those mesh networks, they were considered lossy, right? So some of the protocols were considered lossy, and we've improved, generally speaking, throughputs. But as some of these distribution schemes are pushed out, not only do they require perhaps some more bandwidth, but they require a network that's a higher reliability than some of the traditional lossy networks, that have significant amount of retransmissions and so forth. So as these use cases require more reliability, I think that sort of ties back into the automation piece. Of course, when you're touching 20, 30, 40,000 endpoints, 1% error Seems like a number we could pull out of the air that perhaps people wouldn't balk at. And not only is that a whole lot of truck rolls, but that's a whole lot of assets that would be down during deployment and rollout and so forth. So what are you seeing on the transmission side? Let's dive into the substation here. What are you seeing changing in the substation world? And then we'll bring it back to automation and what you think. What's Burns' and Mac's view on automation and the transmission side?
Yep. Yeah. So on the transmission side, a lot of, and again, I'll speak in averages. Obviously, I can't speak case by case for every single client we work with, but on average, is a lot of automation we're seeing in the transmission space is based around O&M reduction, but a lot of it's driven by using the same staff to do more tasks. As those networks expand, I have more things to manage. I have more things to check, more things to configure, more things to audit as for compliance or external compliance reasons, or even internal auditors within the company itself. And those repeatable tasks cost money and time. And if staffing up operations is either restricted by budget reasons or just lack of skilled labor to hire, the same people are doing more tasks. And how do we take some off my plate day to day? Well, the low hanging fruit is repeatable tasks. Out of those, either through scripting or things like first party tools, network management systems with built-in capabilities for this, starting to more leverage or fully leverage those capabilities so that I am not a human doing a thing that is easy enough, maybe not network changes, but how am I pulling the information and possibly aggregating alarms in a single place or correlating alarms, but how do I simplify the operational views and information gathering in the network? That's a very big area that I've seen in common because it's seen as less risky. And I know, I definitely don't disagree that human error is something we have to eliminate. And kind of the thought of, if I do it myself, I won't, I know exactly what's happening. And if I'm just pulling information, let's automate all that. There's little risk there. But at the same time, if I automate something that changes something on a lot of places, there is the thought, and it's not impossible, that I cause a lot of widespread damage very quickly. So in the transmission space, which is a fairly static environment, a new transmission substation doesn't pop up out of the blue. Those are well planned ahead. Those are easy to coordinate, and they're not happening in rapid fire. Activities on the substation land, also fairly static. So those can be planned. And I think there's been less push to automate things like provisioning as much across the board because it is a periodic task. It is not something, as we were talking about the distribution fan and the speed of deployment, the transmission system is a very planned, and construction takes a lot of time. Projects that drive changes in the substation land take time. So there's time to plan and implement. And it just seems less of a target for automation than the distribution side, which is moving at a very rapid pace.
Yeah, I think I would agree with respect to, if we look at automation from a speed standpoint, the velocity at which things are being put out in the fan far exceeds anything we've ever seen, on the transmission side. I think an intersection for bulk electric transmission substations and so forth, right? So if we look at risk to business, risk of operating the grid and so forth, one of the intersections that I find compelling on automation in the transmission space would be, we need to make sure everything is as it should be, right? So if a transmission substation should be configured in a certain way, I need to know in real time, all the time, that it's done. If a change is made by a human, going directly to site and to the platform and so forth, I need to know that. So some sort of overarching awareness is where I think the value of automation goes to. It isn't the speed, to your point.
Yes, absolutely. No, and accuracy there I mean, that's the mission critical network of all networks. It is supporting the transmission grid where milliseconds matter, and accuracy, I think, far exceeds speed of deployment and change to where, today you have a SDN in the substation LAN is being discussed actively and available to where, the true benefits of SDN would be an automated deployment, say, based on, IEC 61850 model of the substation. That tells me all of the communications, all those settings files from relays tell me what's talking to what. And so I should have a model of what's talking to what that I could compare against the network. And the network should know when anything outside of those defined devices is trying to talk on the LAN. So from a security and segmentation standpoint, all of these kind of come together. And, it'd be nice if I just throw my files in the controller and everything's provisioned, but I don't know that we're quite to that point. But SDN in the substation LAN at first glance seems like, why would I add that level of complexity? But it does bring benefits. The same benefits it brings to a data center, it can bring to that substation LAN. But there is a controller I'm adding and some components I'm adding to the network, which along with that change would bring possibly hesitation into, the transmission substation LAN's been working this way. Why would I go change it? And so it is that kind of give and take of, what ultimately will drive those changes. And it may just be, I need more visibility into that LAN. What's going on internally? And there is a little bit of if it doesn't try to pass through a security device like a firewall, I don't really have visibility to what's behind the firewall unless the network itself is more intelligent.
Yeah, and you bring up a really good point about an architecture like 61850, and I think what I'm seeing is an adoption around the operating model you just mentioned, where 61850 is really prevalent, for example, in Europe. Not quite as bullish yet in the US, but definitely seeing that notion that you mentioned in areas where 16850 is almost the standard at this. Well, it is a standard, but the de facto architectural standard and architecture for a particular type of substation and so forth. So let's dive down to the bottom here and talk a little bit about reliability. I think we've made the case around network automation and human element and so forth. But I want to talk about cybersecurity here. And let me make just a couple foundational comments and then throw it back to you on your thoughts of where just security in general is going. So, I think I alluded to, there's ever increasing cybersecurity and so forth. But before we get to that, I think sometimes cybersecurity, and Dan, let me get your viewpoint on this. Sometimes cybersecurity sort of, or has been, I think it's much less now, has been sort of put off to the side. Is this secure? It gets a stamp and you move on. I think more and more cybersecurity is less of hey, did we do this? It's more a main component of the stool of reliability. And as I alluded to before, this network, the OT network's reliability, is starting to get more and more correlated with the actual distribution of power as reliability. But where are you seeing in terms of, is cybersecurity being pulled into as a reliability component? You still feel it's being separate? What's your view on that?
So if I guess looking at it from security tied directly to reliability, there has been, and the industry has struggled throughout the years of, I need hardened devices to go in harsh environments. And having a sophisticated device that processes a lot of things that goes into that environment has been challenging. Like some of our first projects dealing around NERC version 3 and getting, how do we even find a device that I trust to survive in that environment for very long reliably without actually increasing my operational expense to replace it all the time, has been very challenging. And that's been a challenge where if I can't trust the device that is doing security, whatever it is, I have hindered reliability more than anything else, because the hardware has to survive no matter what. So historically, that has been a challenge. Better options are emerging, and the last few years have been much better about, well, I mean, as processing get more and smaller and uses less power, that feeds into things that I can put in a substation where the air conditioner may fail in the middle of June, or July, and I have to keep running. And I'm not likely going to treat that HVAC as critical infrastructure. And if I can't get to it, that room's just going to be really hot, and I need all of my equipment to keep running, because everything else in that room is designed that way. So I would say I want that picture to start coming together, where you need cybersecurity to remain reliable. And I think we're starting to move in that direction more, versus, oh, the security device is one more thing that can get in my way.
You bring up such a good point, and it brings us back almost 10 years ago, or maybe more, where 6150 started driving this notion of passive cooling, right? And okay, now that I have to be passively cooled, because that was essentially a reliability standard, but by doing so, there's a lot of things I can't do that would have garnered reliability. For example, 2 control cards, right, typically require passive cooling. And so, to your point, I think the vendor industry has moved quickly, quickly at utility pace, to try to bridge that gap, right? So from a Cisco standpoint, using the industrial switches as a security sensor and so on. So, just to go back to cybersecurity and so forth, on the transmission side, again, I would offer the point that is not getting less complex, what we're being asked to do, and I think we've made the point. With complexity comes risk, and one way to mitigate it is going to be with some type of automation, and I think that's where I start to see the marriage. We're just coming up on the end of the time of our session, so I want to, where are you seeing the rate of adoption, right? So we talked about, is distribution sort of leading the charge? Is transmission leading the charge? We talked about the fact that there's 2 separate drivers for both of those. But yep. What do you think the state of automation is in the OT network right now?
The state is, the transmission side is doing what needs to be done to maintain business and reduce the O&M costs and automate the repeatable procedures, because it doesn't have the same drivers as the field area networks do. I think the big driver for automation really will be the need to keep pace with the distribution monetization deployment that communication has to support. Those platforms are going to have to rely heavily on automation for provisioning, firmware updates, everything through the life cycle of that product. That management of those devices will have to be through the central interface, and it's not somebody getting and logging into 10,000 individual devices. That's completely unsustainable. So I really think the adoption of that will eventually move back into automating more in the transmission space. As the value's seen one place where it's necessary, you're going to see more in the transmission space over time, to the automated provisioning and automated network changes based on change tickets or input parameters or what have you that needs to be done. I think we're going to see it more than we are today, and where it's, automated firmware updates or pushing firmware, not doing that manually. That's been in the transport system for quite a while, but I'd say the adds and changes and removes of services, that you're going to see more automation there as the confidence is gained on the distribution side.
Yeah, I think we've seen the same thing, right? From a Cisco standpoint, we've had an automation engine per se on the fan for the better part of a decade. And some of what Marcus is going to talk about is bringing that even more sophisticated, but then now bringing it into the substation. So I think we've seen the same thing. For us, it started in meters and meter collectors, because that had significant volume, and now it's being brought into the substation. But you mentioned something that it reminded me of something that happened years ago and sort of highlights this is we weren't on the field area network, we weren't at the volumes that we are now, that are now tens of thousands. We were in the hundreds or many of the hundreds, and a human-driven firmware upgrade that doesn't go well when these assets are across several states and pushed out. That's something I think we all want to avoid, is having to send a bucket truck out to 150 sites because unfortunately it wasn't done right. So, but that is the benefit of automation and what we're looking to hope avoid and to keep up with the pace of deployment, like you said, Dan. So, Dan, I'll be remiss. Let me quickly stop sharing here. One of the great things I love working with Dan and his crew here is this lab behind him. If folks haven't seen this, so Burns and Mac has this lab that you might see some Cisco stuff off to the side, but it's every vendor that you could possibly imagine, as well as all the substation components. So you can build the test teleprotection, test Flizzr schemes across a field area network, across OPGW and so forth. So it's been a real asset, I think, to the industry. So just wanted to jump out of presentation mode to share that with everyone. So Dan, I really want to thank you in sharing your insights, your viewpoints, Burns and Mac's viewpoints on where things are headed. And appreciate it, Dan. And Marcus, I'm gonna shift over to you here.
Thanks, Jeff.
Thank you. If I can get my mouse here. Oh dear. Let's see. Pardon me. Oh dear. Let's see. Oh, there we go. Okay. Sorry about that, Marcus. So as I alluded to earlier, Marcus leads up our solution validation team, which is Marcus is going to dive in and tell us all about here. Marcus, go ahead.
Great, thanks guys. So yeah, just nice segue into the Cisco validated design. So for those of you that don't know, there's quite a large team at Cisco that focuses on building these solutions. So with the Cisco IoT product portfolio, but also the wider Cisco products as well. So be that enterprise security and a lot of the other products and hardware and software we have at Cisco. So the CVDs really are there to provide you with end-to-end validated architectures that we've tested, give you the best practices from Cisco's point of view, as well as what we learn from customers, and we get a lot of input from customers. And then finally, comprehensiveness. Like I said, we test a lot of the Cisco portfolio, not just the hardened IoT products, and we also test a lot of different third-party products as well, where they're relevant to the solutions. Next slide, Jeff.
Sorry, Marcus, I'm trying. There we go. Sorry.
Yeah, so this is just a summary. There's Cisco validated designs for most verticals that we're involved in. Obviously, utilities and renewables, we've got quite a few CVDs now available on our external website, and we're briefly going to quickly look at substation automation and distribution automation. So next slide. Okay, so substation automation, we've recently refreshed this CVD, and these are the new parts really that we focused on. So the new products at the bottom, so the new switching and routing products, and we'll briefly mention the IR8300 shortly. And really what we're focusing on today are the software, the automation capabilities. So on the right, we've added the Cisco SD-WAN capability for managing the Cisco IR8300 as a substation router, so substation gateway managed by SD-WAN. And on the left-hand side, we've got our Cisco DNA Center platform. So this is where we want to actually manage, provision, the switches as well as the routing platforms in the substation as well. Okay, so moving on to this is a quick look at the architecture, switching and routing in the substation. For those of you interested, we test a lot of different IEC 61850 architectures as well as more traditional architectures. But in red, you can see management and automation being called out. That's really the key topic here, is how we can move away from those manually configured, CLI configured deployments that we've historically seen. Next slide. Okay, so just a quick overview of DNA Center for those of you not familiar. It's an automation platform, well, it's a management and automation platform, but really here we're leaning on the automation capabilities, the abilities for us to discover and onboard switches and routers in a substation and provision the configuration to those devices, doing software upgrades, being able to view our network inventory as well as our network topology. And at the bottom, we've mentioned compliance. So checking we got the right firmware on devices, and also checking the security vulnerabilities that are available from Cisco on these particular products. So you can get it in one place. And then from an assurance point of view, we're really taking the monitoring capabilities. We're looking at the health of the network, the devices, troubleshooting tools, as well as guided remediation to help you replace devices in the network when they're faulty. So there's a lot of good functionality there, and these are some of the key aspects that we targeted in the CVD.
Yeah, and Marcus, I'd call out what we're looking at here just broadly is the full capability. And what your team has done, sort of its first iteration, is pull out what you've highlighted in red here, the items that are most often requested to be leveraged in the OT environment, and then subsequent iterations of your validated designs, in this case specifically to the substation, will start adding more of these blocks in over time.
Absolutely, yeah. It's an evolution, it's a journey. And the CVD will evolve as these customers adopt these technologies, and we get more, we see more complex use cases.
You know, there's something we haven't touched on real quick, and this is this notion of extended enterprise, right? So this is you know, an engine, a software engine that would be leveraged on the largest enterprise networks, and this capability is now, from a Cisco standpoint, being pulled into the OT side. So certainly, we see the earliest adopters of the utilities that already have DNAC on the enterprise side. They've proven out its value, they recognize its value, its impact on reliability and so forth, and they want to extend that method of operations into the OT side. I think those are the ones that have early pressed us to say, you know, on those red boxes, you know, we want this component. So continue if you wouldn't mind.
Yeah, and then the other technology that we've been talking about is SD-WAN. So a way to automate the provisioning and the management of the WAN. So most utilities are deploying large IP networks across the WAN, IP MPLS, cellular, running IPsec over the top. And SD-WAN really basically offers you a really good way to automate the provisioning of that, and then add VPNs on top, do the security, push security policies down. So we're starting to see SD-WAN being adopted now by more and more utilities, and we have recently been validating a number of Cisco industrial routers with the SD-WAN solution, and we're about shortly to release an SD-WAN set of CVDs specifically for distribution automation use cases. So they should be available on our external website in the next couple of weeks. Yeah, and this hammers the same point home. So this is distribution automation.
Right.
And,
sorry.
Yeah. So this is a quick look at a particular scenario. So a Cisco industrial router, IR1101, SD-WAN managed and connecting to Recloser in the field. So we're able to provision the IR1101 and do the ongoing management, firmware upgrades, etc. of that particular platform. We've also validated both Ethernet and serial use cases, okay, running across the SD-WAN overlay network. And this is a slightly different example of a secondary substation, probably more common in Europe, but where we have a slightly larger distribution substation with potentially more devices. Same solution, IR1101 and SD-WAN overlay. And then from a security point of view, we can manage the security policies centrally and push those out to the devices at the edge of the network. So we don't have to be manually configuring access control lists, for example, or zone-based firewalls at the edge of the network. We can do it centrally, and we can do it per VPN as well. So we can have different policies per VPN on the SD-WAN fabric. Next slide. Yeah, so we've got lots of products which are geared towards utilities, lots of hardened IoT products specifically built for utilities. And we have CVDs and solution CVDs that are available on our external website. The CVDs really will take the IoT products and also the wider Cisco products and turn them into solutions that customers can actually deploy. And then finally, we're currently running a promotion on our relatively new IR8340 platform, designed for the substation. It's got a lot of great features: switching and routing in one box, synchronization module, edge compute, cellular support, PoE. I mean, it's an amazing box with a lot of functionality, and we're running a discount promotion at the moment on that particular box until September. So it's an opportunity if you're looking at refreshing the WAN capability in your substation. The 8340 is a pretty amazing platform to do that, and it's SD-WAN capable as well. So we are in the process of validating this box as part of our SD-WAN solution for IP and serial-based use cases as well.
Perfect. Well, thanks, Marcus. Thanks for walking us through at a very, very high level on the validated designs. They can be found on the web. As you can imagine, there's a significant amount of detail that goes into it, as well as not just Cisco, how to configure timing on a substation bus, but what are the protocol requirements for a variety of different utility-specific use cases and so forth. So I wanted to just take a moment, thank Marcus and Dan for jumping on and sharing their insights, the work they've been doing. I did want to just close this with things that are coming up. So Cisco Live, our user group, is coming up June 4th through 8th, where you can get together with you and 20,000 of your closest friends out in Vegas. There's also going to be Utility Summit breakout there. So if you're interested, reach out to your Cisco sales team and they'll help you navigate that process. Cisco and Burns McDonnell are doing 3 trainings across the US coming in the fall. That'll incorporate some of Dan's teams talking about things like, where is NERC compliance? What's the intersection of that and network design? What are substation networks looking like, as well as some hands-on lab work. And then, of course, as Marcus mentioned, the 8340 promotion that'll be going on up until the fall. So with that, I want to thank everyone so much for giving us an hour of their time today and talking about network automation in the OT space. I think what we've left you with is things are moving in that direction, and so we wanted to just bring some awareness into the industry, as well as just touch briefly upon the capabilities that Cisco has. So thanks again for Dan, Marcus, and everyone else for joining. Have a great rest of your day.